Hello, fifth graders. Ms. Jagodnik here again. Today we're going to be working on lesson 12.3, which, as you can see on the chart, is all about solving problems using data in a line plot. So for the last couple days, you've been working on making your own line plots and answering questions about line plots, but they've been relatively simple questions where you're either looking at the numbers in the data and counting up how many people answered a certain way, or you're looking at the total number of people who answered, where you're either counting the data or you're looking at the bottom for a certain value. Now we're going to be talking more complex problems and how you might solve them. So I have a couple of line plots that were given to you on page 713, which hopefully you at least looked at and tried a little bit on your own. And now we'll go over how to solve the questions that they asked you. So we're starting with the guided practice at the top. You have this line plot right here, which talks about the amount of salt that is left over in certain containers after an experiment of some kind was done. So I know that these numbers are given in grams. So I see that my line plot goes from 1 gram all the way to 7 grams, and the whole numbers here are labeled. But I also see there's some hash marks in between that do not have labels on them. So that's something I might have to look at a little more carefully when I'm solving my problems. I see the title is amount of salt left, and I know that each one of these dots represents one container. How many grams of salt was left in that one container? And these numbers at the bottom are the grams of salt. So if I look at the first question they've given to me, what is the difference between the greatest amount and least amount of salt left? So I'm talking about the greatest amount and the least amount of salt. If they asked me how many beakers or how many containers or something along those lines, then I would know I was counting dots. But because they're asking me about the amount, the number of grams of salt that was left, I know I'm going to be looking at the bottom, the numbers on the bottom of the line plot. So what is the greatest amount of salt that was left? Well, if I look at my line plot all the way to the right, that's where the greatest amount would be on a number line. I see 7. 7 is the greatest number here, and it has a bunch of dots over it. So I know a bunch of containers had 7 grams of salt left. So I know that's my greatest amount, 7. To find the difference between the greatest and least, I know I'm going to have to subtract. So now I just need to figure out what my least amount is. So if I look at my least amount on the line plot, I can see that the smallest number on the line plot is 1. But there weren't any containers that only had 1 gram left. So that's not the least amount of salt left. The least amount of salt left is the smallest number on my line plot that has dots over it. So I'm talking about this one right here. This one is one of the unlabeled hash marks I noticed before. So I know if there is one empty mark in between 2 numbers, it has to be the halfway point. So since we're counting in whole numbers here, those will obviously be the halves. So this is the one between 1 and 2. That means it has to be 1 and 1/2 grams. So in order to get the difference between the greatest and least, I would have to do 7 minus 1 and 1/2. I thought I might need to do some calculations today since these are more complex problems, so I did bring some extra paper with me. 7 minus 1 and 1/2. Here's a chance to review our fractions and mixed numbers. I am trying to subtract 7, a whole number, minus 1 and 1/2, a mixed number. That means I have a 0 here. I cannot do 0 minus 1/2. I cannot subtract up. I need to regroup and borrow. So I'm going to take a whole away from the 7 and make it 6. If I am taking 1 whole away, and I'm talking about halves, that's the same as 2 halves. So if I take away 2 halves minus 1/2, I have 1/2, and 6 minus 1 is 5. So the difference between the greatest amount of salt left, 7, And the least amount of salt left, 1.5, would be 5.5 grams. Okay, let's go on to the next problem. We're skipping number 2 if you're following along in your book, because number 2 asked you to make up your own problem about the line plot, and you can certainly do that. That's nice practice predicting what kinds of questions they might ask you about it, but we're not going to do that together. So you can go back, do that one on your own. We're going to move on to number 3. Number 3 is a very complex one that asks you to write and solve an equation for finding the total number of grams of salt left. So this is a little bit like what we've done the last couple days when you had to find the total number of people that answered the question, or the total of number of plants that somebody had, or the total number of teams that scored. Then you would count up all the dots all together on the graph. But this is not quite the same. This is not as simple as counting up dots, because it's not asking you how many containers. It doesn't want the total number of containers, then I would be counting up dots. It wants the total number of grams of salt left. So I'm not just going to count every dot as one. I'm going to count each dot as whatever its value is on the bottom of the line plot. So for example, this dot here is not 1 container because I'm asking about grams. This dot here is 1 1/2 grams. So for every dot on the line plot, I'm going to have to assign it a value based on what number it is over. So I see I have a whole group of them here. I'm trying to write an equation, and now I'm talking about a bunch that have the same value, so I'm going to use multiplication. I have 1, 2, 3, 4, 5, 6, 7 containers here that had 1.5 grams of salt left. So I'm going to start my equation with 7 times 1 1/2. Okay. The next thing I can skip all the way over here is 4. Okay. I also have 2 containers that each had 4 grams of salt left. Okay. Now I skip over here and I see that I had 1, 2, 3 containers that had, unlabeled. It's halfway between 6 and 7. So this must be 6.5. So I have 1, 2, 3 containers that each have 6.5 grams left. And then I have 1, 2, 3, 4, 5 containers that each have 7 grams left. And that's going to equal my total number of grams. Okay, now to figure that out, I definitely need some extra space here. So I have 4 different parts to my equation. This part is easy, that's going to be 8, and this part is easy, that's going to be 35. But in order to solve these two, I'm going to have to do a little extra work. So first I have 7 times 1 1/2. Okay. This seems easiest maybe to make into an improper fraction. So I could rewrite this as 7 times 3 halves, because 1 whole would be 2 halves plus 1 extra would be 3 halves. So that to me is easier multiplication. I do the 7 times 3 is 21 halves, and then I can turn it into a mixed number. So 21 divided by 2, that means I can make 10 wholes out of this, because 2 goes into 21 10 times. That gives me 20, and I have 1/2 left over. So now I know that 7 times 1 1/2 is 10 1/2. Okay. The other one I have to figure out is 3 times 6 1/2. That's not as easy multiplication, so I think I'll do this one separately. I know that's the same as doing 3 times 6 plus 3 times 1/2. 3 times 6 is 18. 3 times 1/2 is 3 halves, or 1 1/2. So altogether it would be 19 1/2. Okay. So this part equals 19 1/2. So if I want to get my whole total, okay, I've got 35 plus 19 1/2 plus 8 plus 10 1/2. So now my 2 halves come together. That equals 1 whole. And then here I have 9 plus 8 is 17, plus 5 more is 22. Okay, that's 5, 6, 7. Looks like I have 72 plus that 1 extra. So I have a total of 73. Okay, so altogether my total number of grams of salt left, I had my equation, and now I just figured out that that equals 73 grams. Well, that was a lot of steps for one problem. Luckily, the next problem is a little bit more simple. It goes along with what we just did. The last problem about this line plot, number 4, says, how many grams would be left if 2 of each container were used? 2 of each, okay? How many grams would be left? So again, this is a total question where I want to add up all the total of the grams. I already did that for what was on the line plot, and we just figured out the total was 73. Now we're just talking about doubling it. 1 of each container gives me 73. If we had 2 of each, it would be another 73. It would be exactly the same. So for this, all I have to do is 73 times 2. Or you could use repeated addition, of course, and do 73 plus 73 if you find that easier. Either way, I come out with 146. So if I double it, the answer to this question would be 146 grams. Okay, so those are some more complex problems that might go along with a line plot. Really quickly, I want to give you another chance to practice each of those kinds of problems. So if I look at the line plot on the bottom of this page, you see you'll have some similar problems. I see this one is about lengths of string. I don't have any empty hash marks, so I can see it goes from 12.5 to 13 and 1/8. We are counting by eighths. It doesn't always look like it because everything is in simplest form. But this would be the same as 6/8. This would be the same as 4/8. These measure the inches of the string. So when I have a problem like this that asks me to write and solve an equation for finding the total amount of string, that means the total number of inches, then I need to do the same thing I just did with the salt. I need to think about how many dots are on each value, and then I need to multiply that number of dots times the value underneath. So my equation for this one would be 2 times 12 and 5/8, because there's 2 dots over 12 and 5/8, plus 1, 2, 3, 4, 5, 6, 7. 7 times 12 and 3/4, plus 1, 2, 3, 4, 5 times 12 and 7/8, plus 1, 2, 3, 4, 5 times 13, and finally 1, 2, 3, 4, 4 times 13 and 1/8, okay? And that would be the total amount of string. Okay. We're not going to do that together now because I'm running out of time on my video, but you can look back at what we did for the previous one, the procedures for multiplying those mixed numbers, and your final answer, I'm going to tell you, should be 296 and 3/8, so that you can check your answer and see if you did the calculations correctly. Okay, we are going to talk about the last one quickly because it's a little different. This one asks for the difference in length between the longest and shortest lengths of string. So I need to find the longest and shortest numbers that have any value on the chart. Looks like this is the smallest one, and this is the biggest one that have dots over them. This doesn't count because it's empty. So I'm going to do 13 and 1/8 minus 12 and 5/8. Once again, I'm going to need to borrow. So take away a whole and make this 8/8 plus the one I already had is 9/8. And I'm going to come up with 4/8. That's equivalent to 1/2. Okay? And that would be 1/2 an inch. See you later.